Okay, so let's talk science test scores. I wanted to take a deeper dive into the science test scores I've been researching, and I wanted to share some of that information with you all. But before I do, I want to talk a little bit about the method I'm using. So all I'm doing is Radatazing science test scores. Radataz is the best way to research, learn, or understand any topic. It really is just the way scientists do science. And so you can see, the first step of learning anything is to read or research or receive some piece of information. And so that's all I did. I was reading about science test scores, and I'll share that with you in a minute. And that got me thinking about some of my own questions. So the next step in Radataz is to ask your own questions. And so that's all I've been doing here, is asking my own questions about the science test scores I've been reading about and researching. And then the third step of Radataz is to test, tinker, try. To essentially play. And I want to highlight this piece of the Radataz process because this playful sort of testing and tinkering and trying part, this is the fun part of science. It's the fun part of trying to figure out how to do anything, whether you're learning about science or whether you're learning about politics or even just how to bake a cake. So this is the play. I'm just testing some ideas out. I have some thoughts. I'm collecting some data, I'm graphing that data and putting it into a variety of different charts, and I'm just playing with it. And then from this, I am answering my own questions. I am testing some ideas. I'm trying to come up with an answer to my own questions about those ideas. It's not set in stone. I'm not publishing a research article. I'm not, submitting it in front of a committee. I'm just playing with some ideas and saying, hey, these are some of the answers that I'm coming up with. And the last part of Radataz is one of the most important parts of doing any sort of research, and that's to share it with others. So I'm talking about it, I'm telling, I'm trying to get other people interested in what I'm exploring. And that's Tazzle, that's Talk, Tell, and Dazzle. I'm wanting to share these data with some of you all. And those of you who are interested, I want to encourage you to go and test the data for yourself and then tell me about it. And so we can talk about it and we can compare our results. And this is the best thing about, doing any sort of scientific endeavor. And I believe it's true across all disciplines. The more we can share with each other our thoughts and ideas, the more we learn from each other. And so that's what I'm doing here. I'm Radatazing, I'm researching, I'm asking my own questions, I'm playing with the data, answering, coming up with some answers, and then I'm sharing that with all of you. Before we dive deep into the actual data that I've been looking at, I want to say a little bit about that data. So for those of you who are curious, I'm just pulling off the data from a variety of education department websites. So I go on to do a Google search for, say, South Carolina test scores 2019, and I go into their various pages and I try to pull out those scores. And so this is a science test scores that I pulled up from South Carolina. I am looking for the column that says meets or exceeds expectations. So I am being very consistent with which data I am using. I'm using the meet or exceeds expectations in all the future graphs. Sometimes, though, I can't know where the data is coming from. So these two charts down here are from Massachusetts. I was not able to find the 2019 high school test scores yet. But these two graphs gave me a summary of test scores between 2008 and 2018. So I'm using the 2018 scores. There are some inconsistencies with the data, even within a given state. You can see these are, I don't know these tests. These are called ST, there might be different tests that they're using. I don't know enough about how Massachusetts scores their students, but I'm just going to trust that the data that they're showing here are the percent of students proficient or higher for 5th, 8th, and high school. The other way that data comes are on these big spreadsheets. This is an example of a spreadsheet from Colorado. And I like these because it gives me lots of data to look at. If I wanted to go back in and ask the question, how many students took the exams, I could do that. It gives me a breakdown of the different performance levels. But again, I'm looking at this percent of students that meets or exceeds their expectations. So this is the column that I'm pulling the data off of. I take that data, I put it into my own Excel spreadsheet, and then I did these quick little spark graphs just to see if I could see a trend. So this is just sort of my sandbox, if you will. I'm just throwing the data in here and I'm just taking a quick peek at it. I started looking at English and language arts. I've got one for California and I'm noticing a different trend already. I haven't completed this one, obviously. And then I take these data and I put them, transferring them into an infographic program online called Venage. And I like this program because it allows me to make some nice looking graphs. It will allow me to change this Y scale, but it doesn't always allow me to do that. So sometimes it won't let me spread the data out or squish it down. And so let me say a little bit about that. The Y-axis does change in some of these graphs. You'll see some of them are going to be up to 40, some of them may have 60 or 80, and some may be to 100. That's okay. These data are all the same, and I've tried to illustrate different ways to represent the data, one with the Y scale showing, one without it showing. Actually, when I asked Venage to pick the parameters for me or settings for me, this is what it gave me. It wants me to graph it between 5 and 20, and it just pulls the data out. And sometimes that's useful because I can see the difference between these two lines more clearly than I can in these representations. Here, I've changed the divisions every 5, whereas these are every 10. So there's a variety of different ways to represent the data. And that's okay. Again, I'm just playing with it. I'm just trying to figure out if I can see this trend or this dip. So the question is, how did this get started? I was reading about test scores and I wanted to see how we were doing internationally. So this is a summary of the TIMSS score, the International Results for Mathematics and Science. And I noticed that United States is here in the 9th position for grade 4. And then I flipped over to the grade 8 test score and noticed that we had dipped down to the 11th position. And the question that I asked myself was, wow, okay, so can we see this state to state? Why is there this dip between 4th and 8th grade? Why aren't we getting better at science? Why are we seemingly getting worse at science? Could I pull that dip out or notice it in individual state test scores? And so that's what I did. I asked the question, can we see a dip in US science test scores? And so I started looking at individual state scores I showed you the data for, and then I graphed them. And what I discovered was that overall, there is a consistent dip between the elementary and mid and high school grades. Sometimes there are some states that seem to recover that dip. Again, I don't have any information about the specifics of these exams, so I'm not comparing scores between states because they're not the same tests, but all I'm looking for is this dip. And yes, some states do seem to recover, but by and large, most states seem to dip between grades 5, 8, and high school, or between the elementary, mid school, and high school grades. So the next question that I asked was, are girls causing the dip? I've grown up my whole life hearing that boys are simply better in math and science than girls are, but I'm not seeing that the girls are causing the dip. So the answer is no. You can see that the girls and the boys scores align pretty closely in all of these states. So girls sometimes do better than boys sometimes do better than girls, but by and large, these map on pretty identically. So girls are not causing the dip in these test scores. The next question I asked, are certain ethnic groups causing the dip? We all know that some ethnic groups perform or outperform other ethnic groups, and that's for a variety of different reasons. And what I'm seeing is that some ethnic groups start at a lower starting point, but even the high-performing ethnic groups show this dip. So the next question I asked about was gifted students or students from low-income households. If we pull those students out, can we see a difference? And the answer is that even gifted and talented students show this dip between elementary, mid school, and high school. Yes, the non-gifted and talented students start at a lower level, showing the dip. Reduced free lunch. Students who are not of low-income households show a pretty significant dip. Even this is just for Colorado, but there's still this dip occurs. So what's causing the dip? Well, I've been asking around to some of my colleagues. So I see this dip in high school. What do you think? Why do you think student test scores dip in high school or sometimes in middle school? And one of the answers that comes back quite frequently is that it's always the teachers. It's all the teachers. The teachers simply in high school don't have enough science education to teach a good quality high school class. And that might be true for some teachers. I'm all in favor of better teacher prep and giving teachers more science, but it's hard for me to believe that all the teachers across all the states, across all districts, are simply not good enough teachers to teach high school science. I don't believe that that's true. The same with parents. Sometimes I hear that it's the parents' fault. The parents are simply not engaged enough with their kids and helping them with their homework and getting them involved in their coursework and learning. And that could be true. Definitely there are some households that would do better at this than others, but I can't believe across the board that it's all the parents' fault for the reason that the students are dipping in high school. Well, what about the administrators? What about the superintendents, the principals, and those decision makers, and the bureaucracy that surrounds public education? Is it just because they're mishandling all of these schools? And again, it's hard for me to believe that all of those administrators are just doing a bad job across all the states and all the districts and all the schools. So I don't think the problem is happening or being caused by the teachers, the parents, or the administrators. So is it the problem with the kids? Should we just blame the kids? The kids are less interested in science. They're not learning as much. They're more distracted by digital platforms and so on. And I do believe that could be true for many kids. It's definitely a different world than I grew up in, with lots of opportunities for distraction. But it's hard for me to believe that all the kids across all the states, across all districts, are simply checking out and unable or lazy to learn science. There's a lot of kids that I run into that love science, especially in the elementary grades. There's a passion they have. There's a dream they have. They want to be an astronaut or they want to be an oceanographer. And so why is that dream failing for many of our students? So this leads me to the next question. What's the common denominator? There's got to be something that's pretty common amongst all of these different groups. And from my perspective, the common denominator is that everyone actually uses the same books. We teach science the same way, independent of the state, independent of the district, because by and large, everyone uses the same books from the same major publishers. Pearson, Scholastic, McGraw-Hill, Synagogue Learning, and Houghton Mifflin Harcourt are the major publishers. They produce the bulk of the science curriculum, science textbooks. And all of these major publishers, and including some of the more minor publishers, all follow the same formula. And what do I mean by that? Well, they all follow the formula of watering down science in the elementary and middle school grades, where the topics that are taught are generally what I would consider more science survey. So over here is a table of contents from a typical elementary science textbook, and you can see this is their section on plants, but there isn't anything specific about plants. It's like, what do they need? How do they grow? What some plants are alike? How are plants different? It's very much a survey course on plants, a variety of random topics about plants. And then in high school, what happens is that all of this watered down elementary and middle school science gets followed by subject-specific courses in high school. So kids are confronted with chemistry, biology, physics, and sometimes geology and astronomy starting in high school. And most kids simply cannot make the jump. You can see here, you've got all these complex topics in grades 9 to 12, and in grades 4 through 8, more or less watered down science classes where the topics are way more generalized. And then in high school, the way more specific. So atoms and molecules and force and energy and words like xylem and phloem, kids have simply not seen any of this vocabulary. They don't know it. Vocabulary is comprehension. If you don't know the vocabulary, you can't understand what's going on around you. And so that's really what I think is happening, is the common denominator amongst all of these different groups is the fact that everyone is using the same books produced by a variety of different publishers, but they're all following the same formula. And if we don't give kids the basic building blocks for these subjects, they're simply not going to be able to make the jump. And so that's why I created Subject Progressive, Real Science for Kids, and Ratataz. Ratataz and Real Science for Kids are all about giving kids the vocabulary and the concepts, so the terms and concepts of real science one step at a time. So kids in grade 1 start off learning about atoms and molecules and bacteria and force and work and electricity, all the way to grade 8. They see it over and over and over again. So by the time they get to high school, they have the vocabulary. They have some understanding of the concepts that are associated with the vocabulary. And it makes high school learning and then college learning that much easier. So that's my Ratatazing science test scores. I believe that we're failing our students if we don't give them the foundational material in the elementary grades and then the middle school. We're not prepping them for high school and college. And so we're seeing a lot of students that simply can't make this jump. They drop out of high school or out of pursuing STEM careers, perhaps in college. And we see this continued sort of decrease and exodus of students who would otherwise, I think, do very well and want to pursue STEM careers. We have a lot of lost Einsteins in here that aren't able to pursue STEM careers because they simply don't have the right tools. So Real Science for Kids and Ratataz gives kids those tools starting in first grade, where they learn all about the basic building blocks for real science so that they're prepped for high school and college. Thanks very much. That is what I wanted to share.